In this video, I'm excited to share a deep dive into the new AI agent features in Cerb version 11.1. We're going to use Cerb to create an AI agent from scratch with tools and custom knowledge. Here's a quick preview of the agent we'll be building. The agent has two tools that give it access to our latest documentation. It can use a semantic search tool to find facts and examples from nearly 1,000 topics. And it has a fetch tool to read the full content of the most relevant matches. We get real-time feedback when tools are used, and the agent also has memory so we can ask follow-up questions or add instructions. In this example, we're asking the agent to review our homepage using marketing best practices. Then we ask it to actually write new copy for each suggestion. You can build new agent tools in Cerb in a few minutes using only your web browser. The agent can be added to any website with a single line of code. First, log into Cerb as an admin. You're going to need a Cerb version of 11.1 or later. Open the search menu in the top right and select Portals. Click the plus icon in the top right of the work list pop-up. Name the portal AI Agent. Select Website Interactions for the type and use the path AI-agent. Click the Save Changes button. Click on AI Agent in the work list to view its profile page. Select the Configure tab. This portal enables you to display interactive Cerb automations as a pop-up on any website by adding a single line of code. It also provides a built-in page for testing. The first thing we need to build is the website interaction automation so website visitors can chat with our bot. Open the search menu in the top right and select Automations. Click the plus icon in the top right of the work list pop-up. Name the automation example.website.agent. For the trigger, click the magnifying glass icon and select interaction.website. We'll start off simple and add more capabilities as we go. In the code editor, clear the default code and type the following: start, enter. Every automation begins at the start command. Now type space, await, enter. The indentation with spaces is very important in our programming language, Kata. Indented commands form a tree, a parent-child hierarchy. Awaiting is the primary feature of interactions. When we enter the await state, our automation will pause until it receives more information from an external source. In this case, that's a website visitor who starts chatting with the bot. Now type space, form, enter. We can await information from different sources. Here we'll display a form and resume once the visitor fills it in. Type space, title, AI, agent, enter. This title will be displayed at the top of the interaction pop-up. Type elements, enter. A form is a collection of UI elements, like text, images, sheets, and inputs. Let's display some text to prove everything works. Type space, say, enter. Space, content, space, hello, exclamation. The say form element displays arbitrary text. The content option displays formatted markdown syntax, where message instead would have displayed plain text. Click the Save Changes button at the bottom of the pop-up. Click on the search pop-up and press the Escape key, or click the X icon in the top right. We can now link our interaction to the portal. In the Interactions section, near the middle, click the plus icon and select example.website.agent from the list. With an interaction portal, we can add links and buttons to our website to start different interactions. We can also send direct links to specific interactions. Those are all configured in this section. The first matching automation is used. We can use the interaction placeholder in the disabled option to match specific interaction names. For now, we just need a single automation, so this works. At the bottom of the portal editor, click the Save Changes button. Now select the Deploy tab at the top of the editor. In the built-in URL section at the top, right-click on the link and select Open in New tab. switch to that tab in your browser. You'll notice that the page is blank. The portal doesn't start an interaction by default. In the browser URL, you can append an interaction name like example to the path. Anything will work right now since we set up our automation to answer every interaction. Press the Enter key, and you should see the example hello message from the interaction. This obviously isn't very impressive yet, but it should be clear that you can send people interactive links for all kinds of things: chatbots, satisfaction surveys, signups, renewals, troubleshooters, pretty much anything. Switch back to the Cerb browser tab, click on the Configure tab at the top of the editor again. We can add a bot icon to the portal to start the chat. This is how it would work on your own website. At the bottom of the portal editor, click into the Portal Website section. Type layout, enter, space, badge, enter, space, interaction, chat, enter. Click the Save Changes button at the bottom. Now when you switch back to the Portal Browser tab and reload the page, you'll see a floating icon in the bottom right when the chat pop-up is closed. Switch back to the Cerb browser tab. Now let's actually build a smart AI agent to chat with. I'm going to use Anthropic Claude as the large language model. Pause the video and create an Anthropic account if you don't already have one. Check the description for the link. Open the search menu in the top right and select Connected Services. Click the plus icon in the top right of the search pop-up and select Anthropic. Paste your API key and click the Create button at the bottom of the pop-up, then close the other pop-up behind it. Since we've already linked our automation to the portal, you can hold Control on Windows or Command on a Mac and click on the automation name in the Interaction section. Now click the Edit button at the top of the pop-up. Rather than hard-coding hello into the chat, let's have a language model generate the welcome message. On line 2, add a new command above await. Make sure it's indented 2 spaces like the await command. Type llm.agent:\enter. Space, output, space, results, enter. This is the variable where our output will be saved for use later in the automation. Type inputs, enter. Space, llm, enter. Space. Select Anthropic from the autocomplete menu and press enter again. Space, and select Model from the autocomplete menu, then type space, and select Claude-3-5-haiku-latest from the autocomplete menu, then press enter again. Select Authentication from the autocomplete menu, type space, and select Connected Account from the autocomplete menu, then type A to select Anthropic, and press the enter key again. This links your Anthropic API key to this AI agent and selects the Claude Haiku model. Now we need to give instructions to the agent. Press the backspace key twice so your cursor is at the same indentation as the LLM command a few lines above. Type S and select System Prompt from the autocomplete menu. Press the right arrow key to unhighlight the text and then press the enter key. Finally, we'll send a user message to the language model so it can generate a response. This will be hard-coded for now, but we'll change that very soon. Press the backspace key once to indent the cursor at the same level as System Prompt. Type M and select Messages from the autocomplete menu. Press the Enter key and type space, then select Message from the autocomplete menu. Press the Enter key again and type space, then select Role from the autocomplete menu. Press the Enter key and select Content from the autocomplete menu. Press the spacebar, then type hello, exclamation. We need to give our automation access to use the llm.agent command. Click on the Policy tab at the bottom of the automation editor. On line 2 of the policy editor, indent 2 spaces as a child of commands. Type llm.agent:\enter. Space, type A, and select Allow from the auto-completion menu. Select the Run tab at the bottom of the automation editor again. Press the play icon in the Input section of the Run tab. In the Output panel in the lower right, you can see the state of the automation and inspect all of its variables. If you scroll down slightly, you should see the results variable set by the llm.agent command around line 11. It is a dictionary with two child keys, session_ID and messages. Messages is an array, a list of messages, and each has the keys type and content. In the automation editor at the top, we can use the new variables to display the LLM response. This is in the say command in the form we created earlier around line 20. After content, replace hello with two open curly braces and type results. Because the results variable is a dictionary, we need to reference its children in dot notation. Type a period and the word messages. Recall that this is a list of messages. We can access list members with square brackets by counting from 0. We only need the first one for this example. Type open square bracket, 0, close square bracket. We're now referencing the first message in the list, which is another dictionary. Type a period again, and the word content. Now type 2, close curly braces. What we just wrote between the curly braces is called a placeholder. At runtime, Cerb will run the scripting syntax and replace the placeholder with the dynamic content we asked for. In this case, the results of the llm.agent command and the content key of the first message inside it. Click the Save and Continue button at the bottom of the automation editor. Switch back to the Portal Browser tab and start a new chat. There will be a bit of a delay while the language model does its magic, which we'll fix in a moment. And then you should see a new AI-generated welcome message. Now we need to be able to chat with the agent. Switch back to the Cerb browser tab. We need to add a text input to the bottom of the form. Move your cursor to the end of the content command around line 20 and press the Enter key. Press the backspace key once to the same indentation as the say command. Type the letter T and select text from the autocomplete menu. Replace prompt_text with prompt_user. The text typed by a user will be saved into this variable. Press the Enter key and 2 spaces. Select Required from the autocomplete menu, press the spacebar, and type Yes. This will require a user to type text before continuing the interaction. Press the Enter key again, then select Placeholder from the autocomplete menu. Press the spacebar once, and type open parenthesis, ask a question about Cerb, close parenthesis. At the top of the automation, we only want to run the llm.agent command if we have user input. Insert a new line below the start command and indent it 2 spaces. Select Outcome from the autocomplete menu. Replace the text key with has input, no spaces. This is just a friendly label to help us tell outcomes apart. A standalone outcome command is just a single conditional statement, like an if in most programming languages. When the if condition is true, the commands in the then branch are executed, otherwise they are ignored. Replace the word condition with prompt_user. This means the outcome will be true when that variable contains text. Under the then command, remove the extra blank line with the backspace key. Fold the code for the llm.agent command by clicking on the down arrow next to the line number in the left gutter. This will collapse the whole command into a single line. Highlight the entire line for llm.agent on line 5 and press the tab key twice to move the command inside the then branch. Click on the line number or the icon at the end of the line to expand the command again. For the message content, around line 17, we'll use the user's message instead of the hard-coded hello text. Replace it by typing 2 open curly braces, prompt_user, then 2 close curly braces. Similarly, we don't want to show the say command before a user types anything. Move your cursor to the end of the content command inside say, around line 23. Press the Enter key and select Hidden from the autocomplete menu. The default is yes to always hide the form element. Let's replace that with some scripting. Type 2, open curly braces, the word results, dot, messages, space, is space, empty, and 2 closing curly braces. This will hide the form element if we don't have a response from the language model yet. Chats are a sequence of turns. We can handle this in our automation by adding an infinite loop. Highlight everything from the start of line 2, outcome, to the bottom of the automation script. Press the Tab key twice to indent everything. Insert a new line below line 1, start, and indent it 2 spaces. Type the letter W and select while from the autocomplete menu. Replace the entire condition placeholder with the word yes. This creates a loop that will repeat forever. Delete the blank line below the do command to keep things tidy. Now click the Save and Continue button at the bottom of the automation editor. Switch back to the Portal Browser tab and start a new chat. You now have the first turn and can type something like "What is Cerb?" ? After pressing the Enter key or the Continue button, you'll get an answer from the language model. At this point, we're only using knowledge from the model's initial training. It has a general idea of what Cerb is, and it can also answer questions based on common facts, like who is Beethoven, or what is Docker? Notice that each time you ask a new question, the history is reset. Let's fix that. Switch back to the Cerb browser tab. Scroll down to the bottom of the automation script. Instead of the say form element, we can use a special element called LLM transcript. This will automatically manage the chat history. Above the say command, type the letter L and select LLM transcript from the autocomplete menu. Rather than displaying messages directly, we can pass a session ID to the transcript element and let it do the work for us. Move your cursor to the end of the blank line below LLM transcript, around line 26. You should already be indented 2 spaces. Type the letter S and select session ID from the autocomplete menu. Replace the sample session ID with a placeholder. Type 2, open curly braces, the word results, dot, session underscore ID, and then 2 close curly braces. Now delete the old say command and its content, but keep the hidden command so it's indented inside LLM transcript afterwards. On a Mac, you can use Command D to delete the current line. If you're not sure what a keyboard shortcut is, you can click on the Editor Commands button in the toolbar above the editor. It's the one that looks like 3 sliders. Type something like remove line to run the command or inspect the shortcut. Let's test the new transcript. Click the Save and Continue button at the bottom of the editor. Switch back to the Portal Browser tab and start a new chat. Ask, "What is Cerb?" again. The response looks better. It shows the user prompt at the top, and it has a button to copy the response to the clipboard at the bottom. If you ask a series of questions, the transcript will scroll down. Something I haven't mentioned yet is that the llm.agent command is managing the agent's memory for us as well. You can ask a follow-up question like, "What is the website?" And the agent will remember that you're talking about Cerb when it answers. Also note that the transcript is still showing our past messages. We did all of that in 2 extra lines of code. The thing that separates AI agents from chatbots is tool use and autonomy. Let's add some tools to the agent to give it specialized knowledge and to let it run actions on our behalf. Switch back to the Cerb browser tab. Adding tools to an agent is easier than you might think. Open the search menu in the top right and select Automations. Click the plus icon in the top right of the work list to add a new one. And we're going to build 2 new tools from scratch, but I'm just going to explain how they work rather than narrating each keystroke. You can pause the video to copy the code. Name the automation example.tool.docs.search. The description here is very important. The agent will use it to figure out what this tool does. Let's describe it as search the Cerb docs and return summaries of pages. For the trigger, click the search icon and select llm.tool. Expand the outputs reference at the top, and you'll notice that an LLM tool takes arbitrary inputs and returns an output named content. The inputs work exactly the same way as other automations. However, the description on each input is also very important because it describes them to the agent. For our documentation search tool, we need an input for the query. It's freeform text, it's required, and the description is the semantic search query with a one-shot example. We provide a public API endpoint to search the Cerb website and documentation. We're going to access that with the http.request command. We'll store the response output in the http_response placeholder. For the request inputs, this is a post request to our public endpoint, and we're going to set the content type header to form URL encoded. The body is actually easy to set, since Cerb will automatically encode a dictionary for us in the right format based on the header. We include the query using the inputs placeholder, and a limit, let's say 10 results. We need to allow the http.request command, so we click the policy tab, define a policy for this command, deny any URL other than our endpoint by prefix, and allow the rest. Switch back to the Run tab. Let's test the tool. In the Inputs section, we'll simulate a user query. What is Cerb? And we click the Run button. In the Outputs section on the right, we can see the response from the API. We just need to return the tool's content as text for the agent. Let's take a look at how the API response is structured. It's JSON encoded. Let's set a variable where we can decode it back into a dictionary. We'll use the on_success branch, which only runs after a successful HTTP request, and we'll reference the response body placeholder. Let's run that in the simulator again. Now in output, we can see a response variable that's much easier to inspect. It has a results key with a list of pages. Each page has an ID, URL, title, content, and tags. It's worth noting that the content on this endpoint is actually a one-paragraph summary of the page. You'll see why in a moment. With that reference in hand, we can now loop through the results to return content to the agent. We use the return command, and we set the key to the expected content name. Because we want to set a multiple line value, we'll add the @text annotation, which allows us to indent any number of lines as a single value. We found that it's very helpful to use HTML style tags as a container when giving blocks of content to an LLM. Let's create a tag called search results. Now inside that, we can use scripting to loop through the pages in the results. For page in response.results, and close the for loop. Now we can output each page in the loop. Let's draw a horizontal line between each page to help the LLM tell them apart, and give the ID, title, and URL. Also, these URLs are relative paths, so we'll add our host name to the front. Then a blank line, and the page summary from content, and another blank line. And that's it. Let's simulate the tool again. In the output section, we can see we're returning the content key with the results. Click the Save Changes button at the bottom of the automation editor. Now we need one more tool. This one is going to fetch full page content by ID when the agent decides one or more of the summaries are relevant. This cuts down quite a bit on AI costs because we're not including 10 full articles of context for every question. This approach also improves relevancy because the agent can search multiple times and keep pulling articles until it has sufficient context to give a well-informed answer. It can mix answers from different searches, or run a second search based on something it discovers in an earlier search. Let's create the second tool. This is also an LLM tool automation. Like the last one, we'll name it example.tool.docs.fetch. And the description is fetch the full content of a documentation page by ID. We have one input, the doc ID as text. It's freeform, it's required. And the description is the ID of a documentation page to fetch the content of, and we'll give a one-shot example. We add the start command like usual. And we're using the http.request command again. Save the output in the HTTP response variable. For inputs, it's a GET request, We use our second endpoint and include the document ID from the input's placeholder. Let's add a policy to allow the command deny any URL other than the endpoint by prefix because the path will change, and allow everything else. Back to the Run tab. Simulate the inputs, which would be a doc ID for, let's say, the docs-intro page, and we'll run that. In the Outputs section, we see that it's definitely the full page content in Markdown format. Let's use the same approach for on_success, where we decode the JSON into a dictionary variable. Preview that, and we see the response has a documents key. And each document has keys for ID, title, URL, and summary. Let's return the content key, again with @text for a multiple line value. We'll say search results to give the agent a hint, and we'll do another loop for the documents. Close that tag. This time we'll add HTML tags to separate each document to help the agent tell them apart. We'll add the metadata, the doc ID, the title, the URL path with our site prefix, a blank line, and the content, then a blank line after each document. Let's test that again. In the output, we're returning that content key and the value looks good. Let's save the tool automation. And now we're finally ready to tell our agent about the tools. After the messages command within llm.agent around line 20, we type tools, enter, space. And we see from the autocomplete menu that there are two kinds of tools we can add. We're going to use automation tools. In a single line, Cerb will automatically describe the automation to the agent for us. For the other tool type, we can implement those in the onTool branch directly in our code. That's really helpful if we want to pause the conversation flow and run a structured interaction like a form, then return that as the tool result. Anyway, let's pick automation for the first tool. We replace the tool name with the actual name of our tool. This is how the agent will refer to it. Let's use docs_search for the first one. The only option we need to set is URI with the format Cerb: automation. And we can just type the letter E to pick our search tool from the list. The second tool is exactly the same. Automation, docs_fetch, URI, Cerb, automation, the letter E, and the fetch tool. And that's it. We just added two tools to our agent, and it has full access to the Cerb website and documentation. Let's try it out. Click the Save and Continue button at the bottom of the automation editor. Switch to the Portal Browser tab and start a new chat. And let's ask it the same age-old question, what is Cerb? This time we have a longer delay, but we get a much more detailed answer. Notice that the agent searched the documentation. We can see that at the top. But we saw nothing until the entire process was done. We can add some real-time feedback to make it feel faster. Switch back to the Cerb browser tab. We're going to add an onTool branch to llm.agent. This is at the same indentation level as inputs. This branch will run every time the agent uses a tool. So we can add an await with a form and render the LLM transcript with session ID, results dot session_ID, and right now this would show a continue button after each tool is used. We don't want that. Let's make the form auto-submit right after showing the transcript. Add a submit element and set is automatic to yes. Now we click Save and Continue again, and switch back yet again to the Portal Browser tab. Start a new chat, and Repeat the question. Now, almost immediately, we get feedback that the agent is searching the documentation. Sometimes, it will also fetch the full content for an interesting page. And then we get the full response. This takes the same amount of time, but it feels much faster because we're not just staring at the waiting spinner going in circles. Something else interesting has also been happening in the background this entire time. Let's switch back to the Cerb browser tab. We can save and close the automation for now. Click on Setup in the top right. Then in the Developers menu, select LLM Agent Transcripts. From here you can review a transcript for every agent chat. Click on a session on the left. And on the right, you'll see the full transcript. You can even inspect the parameters every time a tool is used and see the full tool response. This makes debugging agent and tools much easier. There's a button to share a direct link to a specific transcript. And you can mark transcripts as read once you've handled them. You should review transcripts to see when requests aren't handled well, so you can add more knowledge and tools. For instance, when we first launched the agent on our own site, one of the very first things a visitor asked the agent was for help in recovering their lost Cerb license. The agent had a tool for renewing licenses, and unhelpfully offered to help do that instead. But in under 20 minutes, we created a new tool that let the agent ask for an email address and send a copy of any linked licenses we have on file. We linked the tool to the agent and instantly had a new feature on our website.